idea of consistency. Do we value that? Do we really? What do we mean by consistency? Do you guys know? If you go out and you buy Tropicana cranberry juice, what does it say I'm getting here? 15.2 fluid ounces. Is there some value in going back and buying the same juice and expecting that I get 15.2 ounces? Shouldn't I consistently get the same amount when I purchase this? Is that true? What else? What about food? What's your favorite restaurant? Olive Garden? Oh, there's better Italian places than Olive Garden. What's your favorite restaurant? Sushi Land? Sushi Roku? Benihana's? Who else? No? All right. Let's ask you this. What do you order when you go to Olive Garden? I bet you I know. Fettuccine Alfredo. Right? Am I right? I can guess it. I can guess it. Okay. What if you showed up to Olive Garden and you ordered the fettuccine Alfredo and it was kind of what? It was different, it was strange, or it was just different. Then you showed up a third time and it was even different again. What's the problem with that? It's not consistent. Eddie pointed this out to me. I didn't know this. I didn't even realize it. I've been talking about consistency and statistics all along. He says, in the restaurant business, right, consistency is vital. Why is that? Because people have expectations about what they're going to get. Is that true? And when you don't meet that expectation, what happens? You don't come back. So you want things to be consistent. And everywhere we go, everything we do, we value consistency. When you got these bookmarkers, if some of them look different than others, it would have no value. It's not consistent. Okay? We'll talk more about consistency. How about, I used to use this example all the time. Gary Sheffield used to pay for the Dodgers. Is that right? You guys remember that? And Alex Rodriguez, how much did he used to get paid? I have to change the story because he got a new contract. But you guys remember he signed a 10-year contract for how much? $250 million. And back when Gary played for the Dodgers, he had a good year. And he said, I want A-Rod money. And what did the Dodgers tell him? What did they do? Well, they didn't, well, sort of. They just said, sorry, we're not going to do it. Now, were the Dodgers right in doing that? It's arguable. But do you know why they did not give him A-Rod money? Because he only had an A-Rod year, how many years? 1 or 2 years, maybe 3 over his career. A-Rod has those numbers what? Every year. He was the more consistent player. And so because he was a more consistent player, he had greater value and was paid more. So we value consistency. So we may say, fine, we can't determine who the better bowler is, but we surely can determine who's the more consistent bowler. And if we combine that information with the mean, we might be able to deduce the better bowler. Okay? So we're going to talk about this concept of consistency. Do you guys want to know what the formal word in statistics is for consistency? There's actually 2 words. This is the standard deviation or the variance. Okay? So what we know and love in everyday English language, the word consistency is measurable and called standard deviation in statistics or variance. They're related. And that's what we're going to talk about now. Okay, you guys okay with that? Well, I think what I'm going to do here is give you the story. I mean, I know some other instructors, they're just going to tell you, here's this formula, this is what it does, compute it. I really don't like doing that because I want you more secure with what you're doing. Okay, I want you guys to feel secure. When you're secure about what you're doing, want to know what happens? You do better. You believe in your skills. In the long run, it benefits you. So I'll take a little bit of time to kind of explain this concept and where it comes from. Okay, consistency feels like this. This is how we're going to define it. It's how far, comma, on average, a data set is from its mean. The mean being the what? Center. That's how we're going to think of consistency. How far? How far? You guys know what operation that is in mathematics when you say how far something is? There's an operation associated with it. How far are two numbers from one another? You take the what? The difference. So you're saying how far on average a data set is from its mean, its center. So here's what we're going to do. For Yazdi, we're going to do this. I'm going to list her data values. 185, 170, 200, 185, 225, and 145. Okay? And this is the how far part from its center. Take the data value and subtract the center. What is the center again? The mean. You with me on that? This is how far every data value is going to be from the center, from the mean. So what is the center in this example for Yazdi? So for each value, I'm going to subtract 185. So I'm measuring how far 185 is from 185. How far is that? It's not far at all. It's 0. 170 minus 185, how far is that? Well, it's 15. 200 minus 185 is what? Oh, 15. 185 minus 185 is 0. 225 minus 185, well, that's 40. Is that right? Then 145 minus 185, and that is going to be negative what? 40. This is how far every data value in the set is from its what? What's 185 again? Its center, its mean. Now, how about this? How far on what? Average. This is what we're going to do. We're going to add these values together. We're going to determine the sum, the average of how far they are. So I'm going to add those values together. Then I'm going to divide by how many values do we have? N? 6. That's going to give me the consistency here. Okay? So what do I notice about this? About this sum? What happens when I add these? You get what? Is that 0? And so I go, oh, okay, consistency is going to be 0 divided by, what's n? 1, 2, 3, 4, 5, 6 data values. Oh, the consistency is what? 0. There's a problem here. There's a problem. The problem is such a good idea in definition, right? Measuring how far a data set is